Hello! This is the interim presentation by Team 5 for the class ME 452. We will be going over the analysis and redesign of a valve. Our team is made up of Nicole Basil, Hannah Ho, Layla Mohammed, Zoe Nathanson, and Karen Nee. The valve is a device that controls the flow of water in a piping system by changing the area of the flow ranging from completely open to completely closed. It is very common. The valve that we have chosen is depicted by the images of the CAD model shown here. This, in particular, uses a hand wheel, which means the flow of water can be changed more finely. We have depicted the exploded view of the valve as well. Note the cap nut isn't shown.
Our primary customer for the gate valve would be wastewater management companies, which use a multitude of valves in creating pipe networks, including gate valves, and they would rely on the functionality of these valves to manage wastewater in a city. There would be component variants for pipe networks of a community, as opposed to our secondary customer of plumbing companies, which would replace components of a building's water system, such as using gate valves. They would also rely on the functionality of these valves to make reliable fixes, to keep their customers satisfied, and they would use component variants for pipe networks of a building instead of a community.
We did a functional analysis of a valve, and the primary function of a valve is to control fluid. As you move to the right, we have more functives, and the final functives that we came up with were switch position, create passage, create blockage, withstand pressure, control fluid, and prevent leaks. We also came up with show status to assure convenience.
The function component mapping matrix is used to match the components of the gate valve to their respective functions. As you can see here, most of these components are used to withstand pressure and prevent leaks. The spindle, bridge, hand wheel, and bracket are used to switch positions, while the body is the main part that contains the fluid. On the next slide here, the gate or plunger is used to create and block the passage.
We also did a bill of materials, and there's a lot on this slide, so I won't go into it, but the things highlighted in orange are fasteners, so hopefully we can eliminate those in our redesign. And the overall price per valve that we came up with was just over $650.
Here we have the functional differential table and the component commonality table. In the functional differential table, we see the functions that are the same between the two customer groups: switching positions between open and closed, creating passage, blocking the passage, and ensuring a tight seal that prevents any leakage. For the differences, we have how we show status and how much pressure needs to be contained. For the component commonality table, the components that need to be modular are the hand wheel and the gate. Everything else can be the same between the two customer groups.
Using the differentiation table, we were able to design modifications for the secondary customer's design variant to make the valve more suitable for their use. The handle design was modified from the more precisely controlled wheel to be an on and off handle for the secondary customer. This is sufficient for the plumbing needs for stopping the water flow during repairs and replacements. The plunger design was modified to a rubber stop for ease of quickly blocking and opening the flow of the water when the handle is turned. This view shows the common interfaces between the modules and the platform. The spindle is a common interface for the handles. The primary variant handle is press-fitted onto the spindle, whereas the secondary variant uses a set screw to connect to the spindle. The common interfaces for the plunger variants are the spindle and the bushings. Both variants are rigidly attached to the spindle. The variants interact with the bushings by being spun into and out of it, controlling the water flow.
So here, two feasible assembly sequences were made using fishbone diagrams of the primary variant, and the main difference between these feasible assembly sequences is the order in which the studs and the hex nuts are placed in, and also the order in which the collar pin and the collar is placed in to secure the spindle. Now, the collar and collar pin can be added either before or after the gland is secured with studs and hex nuts. And the second sequence with the collar and collar pin added after the gland is secured with the studs and the hex nuts was chosen because if you were to have to hold on to the gland and the V-filler while the collar and collar pin was being secured, it just makes it more difficult to handle. And now just taking a look at the differences between the primary and secondary assembly sequences. The secondary variant assembly sequence differs from this in the fact that instead of a gate, there is a plunger being added, and instead of a hand wheel, there is a flat handle being added. And finally, these assembly sequences were used to create a product family assembly diagram, and you can see early on there's already delayed differentiation, and there are two variants in which the plunger or the gate is being added, and then towards the end, once the handle is being added, there is two more variants in which either a hand wheel or a flat handle can be added.